Okay, we're I.B.M. Hydro. We're basically, our project is the Las Vegas Valley Wash pump storage system. I'm Efraim Balizan. We have Johnesha Inman and Shauncy Maloy. And basically, the problem is with the growing number of solar power plants, what can be done to counteract the sudden drops in production due to weather from solar plants. One solution that can be done is called pump storage. Basically, what pump storage has been used for in the past is you pump water from a lower reservoir to a higher reservoir during off-peak times to minimize the cost of pumping the water up. And then during high demands of electricity, the water is released down through turbines and then generates electricity. So basically what we want to do is, with the inconsistencies or intermittencies of solar power in town, and as more solar power plants are popping up around the valley, something needs to be done to compensate for this power loss. Basically what we want to do is we want to pump water using effluent water at the base of Sunrise Mountain up to a reservoir on top of the mountain, and then release it through the turbines whenever the power is needed to compensate for the power losses due to solar power. So some of the variables that we're actually considering for our project are up here. The main ones, obviously, reservoir sizes, pump size, turbine sizes, how much power is going to be generated to get this water up to our reservoirs and to save it, capacities and outputs and all that type of stuff. Basically, the next one. By law, Nevada, NV Energy has to go to 25% green energy by 2024. And as of next year, they have to get 12% of their power from renewable energy. So actually, they're going to have to do something to be able to compensate for this extra power that they're not going to have. So this is what that's why we're proposing this project.
As Efraim already kind of spoke to you about, pump storage is traditionally used to offset peak demand. As you can see in the picture, it's pumped up from a lower reservoir to an upper reservoir and stored until it's needed during those peak hours. This particular project will be used to offset also the inconsistencies of solar energy or any other type of energy that you would use due to weather conditions or any other issues that may come about. For commercialization, tax breaks are not available for public utilities, but they are for independent contractors. Therefore, someone such as NV Energy, it will be cheaper for them to have a public contractor to build it for them as opposed to them building it for themselves. As we have spoke about also, the difference in the cost of peak and off-peak power can outweigh the efficiency losses of the pump and the turbine. During peak hours, it's less economical to run these plants. So it's much more economical and more efficient to run it during off-peak hours.
All right, the scope of our project is going to start with site selection. We're going to choose the location for the upper and lower reservoirs, as well as the route for the pipe line between the two. And then we're going to choose a location to connect into the electrical grid. We'll be designing the upper and lower reservoirs or tanks. One of the things that we need to decide is whether or not to go with a reservoir or a tank, what materials we'll be using, and if it's a tank, whether it'll be above or below ground. We'll be designing the pipeline, the size of the pipes needed for the flows that we'll need, the materials to make the pipe out of, and whether or not to put the pipeline above or below ground. We'll be designing the general design of the pumps and the pump station. We'll choose the location, the pump size, and basically what we want the pump to do. We're not going to go into the exact specifics of brands and things like that. We'll just get a general design for the pump station. We'll also be designing the turbines and the generation station kind of the same way. We'll set it up for the type of hydro turbine the size and the output we want. But again, the exact specs of the hydro turbine, that would be up to the manufacturer. If the project was ever built, they would have to come out and give the specifics on their turbines. We'll also do an economical evaluation, give the approximate capital costs, the approximate O&M costs, and an idea of what the return on investment would be. Next slide. And our target generation is at 30 megawatts. Part of the reason we chose this is because 30 megawatts or below with a pump storage system can be classified as green energy. Anything larger than that is not considered green energy, and we want to sell this project as a green renewable energy. And this is just a line that shows, based on your flow in cubic feet per second, how much theoretical generation you can get in megawatts. So that's how we chose our target there.
From where do you get this line? Based on what? Why is it linear?
There's an equation for theoretical power output. It's based on your head of water that you have, your flow rate, the efficiency of your turbine, and it just comes out to be linear because it's a first degree equation. So.
Lastly, this is our Gantt chart for our plans for the rest of the semester. We've already completed the project rationale. We're doing research now, and we'll be continuing to do research for some time, finding different things we need as far as pump sizes and about the different turbine sizes. And after some research is done, then we can actually decide on the pump and the tank design and the pump and turbine design. The preliminary report can be completed after we've finished with those, and then an economical analysis once we know all the design of all the different aspects. Our final report and the AutoCAD drawings will take some time until the remainder of our project. And that's it.